again, here's our main theorem for the section about how to calculate arc length. As it turns out, the integrand right in here, so I just cover up the integral and the dt, the square root of x prime of t squared plus y prime of t squared. This is the speed of the particle. And so our second theorem here, the speed along a parametrized path, the speed of c of t is x of t, y of t, is the square root of x prime of t squared plus y prime of t squared. Two little justifications for this. It makes sense that integrating speed gives you arc length here. I mean, adding up your entire speed when you're driving your car down the road is going to give you, adding up in a particular way, it's going to give you the total distance that you traveled. Also, x prime of t squared plus y prime of t squared, we have some sort of Pythagorean theorem relation going on here. So normally we think of like, here would be x prime of t, here would be x, here would be y, and the hypotenuse of that triangle would be x squared plus y squared. We can do the same thing here, x prime of t, y prime of t, form a triangle, square root of x prime of t squared plus y prime of t squared. That's going to be the speed here. So let's crunch out an example here, and there's going to be a little bit of a twist here, not just speed, but distinguishing between these two words, distance and displacement. I'll get to those words in the second part of the question. Let's just take a look to see what's going on here. Particle travels along the path c of t is 2t comma 1 plus t to the 3/2. So first we have to find the speed at t is equal to 1. Well, to do that, we need x prime of t is, take the derivative of 2t and we get 2. Y prime of t, take the derivative of this and we get 3/2. T to the 1/2. And so then our speed is ds dt is just this square root right here. Square root of 2 squared plus 3/2 t to the 1/2 squared. So that is going to be 4 plus, let's see, 9/4 t to the 1/2 squared is t. And we are asking at t is equal to 1. And so this is going to be square root of 4 plus 9/4 times 1. So that is going to be square root of, actually it's going to be putting, so 16 over 4 plus 9 over 4 is 25 over 4. So hey, that comes out to 5/2 is 2.5 in whatever units that we're dealing with. Okay, so that part of the problem is just a straightforward application of this speed calculation here. Now for the rest of this, okay, distance and displacement for t is running between 0 and 4. So let me distinguish these two ideas here, distance and displacement. So displacement is the net of how far you actually made from your starting point, from your ending point to your start point. So let's say you start here, and you go south 1 unit, you go east 1 unit, and you go north 1 unit. So distance, displacement. So the displacement would be, you've only gone 1 unit away from where you started. That's going to be the displacement. The distance, however, is 1 plus 1 plus 1. That's 3. So the distance is related to, if you run this out, it's going to be how tired you are at the end. It's going, if you're driving a car, it's going to be related to how much gas you're using here. But displacement is just all, you don't actually look to see what happened, you only look to see where you start and where you end. I had a high school physics teacher who liked to annoy students on the track team by saying that's like, oh, let's say you're running some kind of race here and you run around the track several times. If the starting place is the same as the ending place, your overall displacement is 0. You've accomplished nothing. So obviously, there's something to be said for running around, but I've always kind of had that stuck in the back of my mind. Okay, so how do we compute those quantities here? So for overall distance, that's going to be, let me go to a new piece of paper here. The distance is going to be exactly this arc length calculation here. Arc length is going to be the distance traveled, so that is the integral from 0 to 4. We are asked for distance from t is running from 0 to 4 of the square root of x squared plus x prime of t plus y prime of t, and we compute that to be 4 plus 9/4 t here. And so, how do we compute this? We want to substitute in u is equal to 4 plus 9/4 t. Du is equal to 9/4 dt. So 4/9 du is equal to dt. Change our bounds. When t is 0, u is 4. When t is 4, u is, looks like 13. And so, because that is going to be plug in 4 up here, 4 plus 9, yep. Okay, so what do we end up with? 4/9 times the integral from 4 to 13 of u to the 1/2 du. So this is 4/9 times 2/3 times u to the 3/2, plug in 4 and 13. So this is 8/27 times 13 to the 3/2 minus 8, and it's about 11.52. Now for displacement, all we care about is the ending position and the starting position, how far away they are from each other. So how do we do that calculation? Well, okay, we want to know what is C of 4 and what is C of 0. So here's the ending point, here's the starting point. And so the ending point and starting point, we have to actually go all the way back here to our original problem statement here. C of 4 is going to be 2 times 4. And 1 plus 4 to the 3/2. This is 8, 9. C of 0 is 2 times 0. 1 plus 0 to the 3/2 is 0, 1. And so, how do we do this? 0, 1, 8, 9, somewhere up here. Find the distance between these two, and this distance ends up being 8 square root 2, which is about 11.31. So note that the total distance traveled is about 11.5. The net displacement here is 11.3, roughly speaking. So how to explain that discrepancy? We didn't take the most direct path. We didn't go straight from here to here. We took just a bit of a curved path to get there. Therefore, it took a little bit longer.